Good morning. My name is Tom Faller, and today we'll be talking about getting started with binoculars in astronomy. First of all, we're going to be talking several things today. One is what binoculars are, why they're useful in astronomy, what all those numbers with binoculars mean, what the real purpose of binoculars is going to be, what you can see in the night sky with binoculars, and finally, how to buy a decent pair of binocs. Okay, to start with, binoculars are basically two telescopes in a small compact package. Binoculars are built with little prisms inside. In this case, these bend the light in kind of an L shape or Z shape. These are similar, but instead of having an L, they bring the light around a couple of times and shoot out the front. The reason for that is to make them more compact so that you don't have very long tubes in your hand. And it also, by making them more compact, makes it so that front lens isn't ground so steeply and you don't have more optical problems from a very sharply ground lens. These used to be the ones that you'd find all the time, but they are getting maybe fewer and scarcer. I'm not sure why. These, on the other hand, are getting better and better in quality and better in price. So really, it's a toss-up between them. I'm going to talk about them both as if they're the same thing. I have several binoculars in front of me today. These are 10 by 32s, 8 by 40s, 7 by 50s, 10 by 50s, and finally 15 by 70s. Quite an array. Interesting thing to note though is the power of a binocular, which is the first number that you're getting, 10, doesn't necessarily mean the size of the binocular. These are both 10 power binoculars. And the 10 by 50s and 7 by 50s aren't that different really. So another thing you notice here is that I'm going from 7 power up to 15 power, maybe 20 power in some binoculars. That's not really much of a range. Binoculars are designed for low magnification for a couple of reasons. First one is that if you go over 10 power with binoculars, your view starts getting pretty shaky. It takes a lot to hold them still for a long time. And in fact, with the big binoculars, the heavy ones, you really need a tripod to use those for any length of time. And that can be difficult in itself. Big binoculars, when you're holding them like this, are tough to hold, but when you're holding them like this, it gets really strenuous for a while. So you have to take extra provisions. And that brings us to our second number, 10 by 32s. That means this objective lens, the front lens in a pair of binoculars, is 32 millimeters across. 32 millimeters, 50 millimeters, 70 millimeters. So the big feature with binoculars is not so much that they magnify. I mean, at 10 power even, stars are still dots. Planets are mostly dots. And even the moon gets a little bigger, but not that much that you'd want to stare at it with binoculars for an hour. The magnification is okay. Things do get a little bigger, but what you're mostly getting with binoculars is increased grasp of light. Now, under normal daytime conditions, your pupil is only about 2 to 3 millimeters across. But at night, that can open up to about 5 millimeters for older people, or even 7 millimeters for younger people. And that makes a big difference if you're using binoculars. With 32 millimeter lens openings like this, you get about 20 to 40 times the light grasp of your normal open dark adapted eye. With 50mm binoculars, it's more like 50 to 100 times. And with 70mm binoculars, it's 100 to 200 times the light grasp of your normal night adapted eye. This makes a big difference in what you can see. Even at twilight, where you still have some light in the sky, you can see anywhere from a few dozen to up to 100 or so more stars in the sky in the field of view of your binoculars than you will just looking up at the night sky. All sorts of things will become clear. And that's what makes binoculars interesting. You can use them just for searching around on your own, looking at the sky and seeing what you can find, or you can look for specific things. There are an awful lot of things up there that you want to find with binoculars first before, say, you use a telescope. I almost always have to find Polaris, the North Star, with binoculars in the evening sky before I go on to use it to sight in and collimate my telescope. Binoculars are almost an invaluable part of any astronomer's toolkit. And we'll talk about what makes the best binoculars for astronomers and how to get started in choosing them. So, again, we've talked about binoculars having a small, let's say, lens opening versus medium versus really large. This makes a difference not only in how much you'll carry it and how much you'll use it, but how good they are really for astronomy. These binoculars you'll find a lot in birding and hunting stores. And they're meant for use in daytime where the amount of light coming in isn't that big of a deal. Even so, these can kind of run out of steam in dim light conditions or looking into darker spaces. So as far as binoculars for astronomy, we'll kind of put those aside. These, on the other hand, are great. They really pull in a lot of light, but they are really heavy for long time viewing. And without a tripod, it's not the kind of thing that you want to use all night. So we'll concentrate more on these binoculars, say roughly 7 to 10 power and roughly 40 to 50 millimeters of objective lens. So this is what you can expect to see with a pair of binoculars in the night sky. First, go out before it gets really dark. Go out while the sun is setting. Look up and look at the different colors in the sky as it gets dark. You'll see that, first of all, there are stars up there in some of the darker areas. Bright stars can come out even before the sun sets, and planets can show up. Look for planets first over by the sunset, and then in a line stretching across the sky from there. Planets stay in one particular arc, and if you see one planet, you might find more than one. There may be several out in the evening sky. These are a little tougher to tell from stars because they're not quite big and round like you'd expect them to, but if you find Jupiter, it's probably the brightest thing up there, and it may have 3 or 4 tiny moons next to it that you can see with binoculars. You can also see our moon, and you can see a few of the craters and big white splash marks from the craters across the face of the moon. If you look in the darker side, if the moon isn't quite full yet, you'll even see something called Earthshine, which is where light from the Pacific Ocean and its clouds bounces up, hits the moons, and then comes back to your binoculars. As it gets darker, you can start to see satellites crossing the sky. These can come almost anywhere, pass overhead, or just skirt the horizon, but they'll be moving fast. They'll usually look to be points of light, and you can track them with your binoculars as they might vary in light intensity as they move and tumble. Finally, as they hit the Earth's shadow, they fade out and then become invisible. If the space station is passing over it, you'll actually see it pass over as 2 panels of solar panels that are flying next to each other in the night sky. As it gets darker, it really depends on where you're standing, whether you're in a park or in your front yard in the city and the sky's still pretty light, or if you're way out in the country and the sky gets really, really dark. If it gets dark enough, you can start looking for the Milky Way, which will look like little bands of clouds stretched in a string across the entire sky. If you're in the city, you might not see this. But with binoculars, again, you can see so many more stars that you can start looking up in the sky and look for where you see big concentrations of faint stars. Follow that around, see if you can track it. In both cases, as you're tracking the Milky Way, you can start to see little knots and swirls in the Milky Way. And these are the interesting things. These are what astronomers call the faint fuzzies, because they are small and faint and hard to see. They might be anything from small star clusters, with the stars so tiny they're unresolved. They might be nebulas of gas and dust, either from stars being formed or from stars that have exploded. Or finally, you might even see galaxies. There are at least 3 galaxies you can see under dark skies with the naked eye. There's a dozen or so you can see with binoculars. Try and locate these on things like star maps, or if you have a star app on your phone or a pad, use that to figure out where you are, what you're looking at, and then star hop from there to somewhere new. Let's talk about buying binoculars and finding a pair that you're happy with. It may be difficult at this time to find binoculars in stores, but there are stores out there that will let you handle binoculars, and that's a big part of the buying experience. Picking up a pair of binoculars will tell you whether they're light or heavy, whether they're real bulky, how easy they are to maneuver, whether they fit your eyes or they're too wide, and all sorts of other things. If you're buying binoculars in a store, pick them up, try them out, see which ones feel good in your hands. Look across to the other side of the store. What is the farthest thing that you can read? Look at price tags or little signs. That gives you an idea of how good the objectives are to picking out detail. If everything looks fuzzy, your stars will look fuzzy. While you're looking out there, try and see how wide your field of view is. That is, how sharp things are on the way to the edge of your field of view. If the only thing you see that's sharp in a pair of binoculars is right in the center, you're not going to use them for astronomy very long, because everything at the edge is going to look too blurry. Stars at night is one of the toughest tests for any optics, and binoculars should be made to give you a wide, flat-looking field in the sky. Now, I said again before that the really small binoculars shouldn't be your first choice for binocs, because they don't gather enough light, and the really large ones are too heavy to keep you interested. You want something you will pick up and go outside in the night sky whenever it's clear and use. So that means staying with binoculars that are 40 to 50 millimeters in objective and about 7 to 10 power. There's a lot of those out there. And I'm not even going to get into names or brands on them, because there are so many good ones out there, so many new brands, and because the field of optics has been advancing so much over the past couple of years. Go on out, see what you can find, and then make a choice from that. And I would advise that you put a few extra dollars into these, even if you think, well, maybe I'm not going to use them initially. I've had these binoculars for 30 years. These for 25. If you pick out a good pair and put a little extra money in there, you will get that money back in investment. These have been not only the best binoculars I've had, but the longest lasting ones, and have outlasted and outperformed other binoculars I've had. So when you go out, try the binoculars. If you have to go on the internet to find ratings for them, do that, but don't buy from the net first. If you don't handle the binoculars that you're going to get, I don't think you're going to be as happy with them. So that pretty much concludes our talk about binoculars. I hope that next time I have a star party, I see everyone out there with new binocs. Thank you.